In this video, I will discuss the Maxwell equations, which are very important equations in physics. There are 4 Maxwell equations and I will write them in both the differential form and the integral form. The first Maxwell equation is generally known as Gauss's law for electrostatic, which can be written as del dot E is equal to rho over epsilon naught. This is the differential form of Gauss's law. Here del is the general differential operator, E is the electric field intensity, rho is the charge density, and epsilon naught is the permittivity of free space. The second Maxwell equation is generally neglected, but it is often known as the Gauss's law for magnetostatics, which we can write as del dot B is equal to 0. That is, the divergence of magnetic field is 0. Due to this second Maxwell equation, there is non-existence of magnetic monopoles. The third Maxwell equation is the Faraday law of electromagnetic induction, and this equation can be written as del cross E is equal to minus partial B over partial T. Through this equation, electric field and the magnetic field are coupled. That is, the curl of electric field is the negative of rate of change of magnetic field. The fourth equation is the Ampere-Maxwell equation, which we can write as del cross B is equal to mu naught J plus mu naught epsilon naught partial E divided by partial T. Now here B is the magnetic field, J is the current density, mu naught is the permeability of free space, epsilon naught is the permittivity of free space, and E is the electric field intensity. These 4 are the Maxwell equations in the differential form. First one is the Gauss's law for electrostatics. Second one is the Gauss's law for magnetostatics. Third one is the Faraday law of electromagnetic induction, and the fourth one is Ampere-Maxwell equation. Now we will write them in the integral form, and in the integral form, the Gauss's law for electrostatic can be written as surface integral of electric field is equal to 1 over epsilon naught time the integral volume integral of charge density. This is the integral form of first Maxwell equation. Integral form of second Maxwell equation can be written as closed surface integral of magnetic field is equal to 0. And the third Maxwell equation in the integral form can be written as the line integral E dot dl is equal to minus time the rate of change of integral surface integral of magnetic field. And the fourth equation can be written in the integral form as closed integral of magnetic field, this is the line integral, is equal to mu naught times the surface integral of current density plus epsilon naught d over dt of surface integral of electric field. This is the integral form of fourth Maxwell equation. So on the left hand side we have the differential form of Maxwell equation, and on the right hand side we have the integral form of Maxwell equations. This is all about the 4 Maxwell equations which are most often used in physics and electrical engineering fields. I hope now you have a clear understanding of the differential and integral form of these equations. Kindly subscribe this channel for more physics and mathematics videos and concepts.